We're going to be solving equations and inequalities. Section 1-1, we're going to start first with expressions and formulas. Now, some of the things you need to make sure that you are aware of, this should not be new to you, is our order of operations. And you may have heard the little saying, please excuse my dear Aunt Sally, to help you remember order of operations. And that works as long as you are aware of a couple things. Please stands for parentheses, so first you will evaluate everything inside the parentheses. The excuse stands for exponents, so you're going to evaluate all of the exponents next. The my and the dear represent multiplication and division, and you go left to right. So sometimes you will divide before you multiply. These are the same priority, they go left to right. And the Aunt Sally represents addition and subtraction, and again you go left to right. So let's take a look at this first example. So the first thing you would do is parentheses. So as we see here, we're going to have 7 minus 2 is 5. So the only thing that is going to change right now is this becomes a 5. Everything else remains the same. The next step, even though there's a parenthesis here, it's just to set up that that is going to be raised to the third power. There's nothing to do inside the parentheses. Now remember, the brackets do act as parentheses, so we're doing what's inside of those brackets. So the next thing here would be the exponent. You are raising the 5 to the third power. So 5 times 5 times 5 is 125. So this is what we now have. Finishing inside the brackets, the next thing, we have multiplication and we have subtraction. Multiplying comes first, so now we have 384 minus 3 times 125, 375. Finishing off the brackets, 384 minus 375 is 9, divided by 3 is 3. That is our final answer, solving with order of operations. Here is a problem for you to try. Go ahead and try it. Pause the video, and then when you have an answer, come back to this and I will reveal the answer. Okay, you should have gotten 9 on this problem. All right, let's take a look at another example. Now, this time we have an algebraic expression. And when you have an algebraic expression, here we have variables, we have s, we have t, that are going to represent numbers. And actually, in this case, we are just going to evaluate using order of operations. We will evaluate this algebraic expression, and they give us the values that we are asked to substitute in. So everywhere you see an s, you will replace it with a 2. Everywhere you see a t, you will replace it with a 3.4 and follow order of operations. So I start by just replacing 2 minus 3.4 times 2 squared minus 3.4. Now I'm going to follow order of operations. So what do you have here? Well, we do have parentheses, so I'm going to do that first. Inside the parentheses, I have 2 squared. Now it's fine to take a little shortcut. I'm going to just change this to a 4, because 2 squared, 2 times 2 is 4. Now I'm going to do 4 minus 3.4. When you do that, be careful, but you should be able to do that in your head. 4 minus 3.4 is 0.6. So now I'm going to write this down. Okay. Next step. Now be real careful here. Sometimes people want to just go to minus 3.4. Remember that this tells you when you have a number in front of the parentheses, that's telling you to multiply. So the next step is to multiply 3.4 times 0.6. So when we do that, you get, I guess we could grab a calculator, but we don't need to. 2.04. And then you subtract, and you get negative 0.04. And that would be your answer. Okay? You go ahead and try one. Substitute the values. evaluate it using order of operations, check your answer. So go ahead and pause the video and restart it when you're ready. You should have gotten negative 110 when you worked this out. Okay, so you can double check, go back and check and see if you can find your mistake if you made a mistake. All right, on this next problem, again, another algebraic expression. One thing, just let me mention, next, I think tomorrow, or we'll be looking at some equations, that how you can tell a difference between an algebraic expression and an algebraic equation. Notice here there's no equal sign. It's just an expression. So again, we're going to start off the same way. Substitute the values and simplify. So I'm going to start by doing 8 times 5 times negative 2. And since it's a negative, I'm going to put it in parentheses. Plus negative 1 cubed all over negative 2 squared plus 5. Now what I'd like to do for just a minute is to point out to you on your calculator, if you type in negative 2 squared, just like that, you will get negative 4. But that's odd because you know that when you multiply negative 2 times negative 2, you get a positive 4. What your calculator does is it follows order of operations, and it's evaluating the exponent first. 2 squared is 4, and then it does the opposite sign. If you want to square a negative 2, first of all, I would like to point out, why would you ever need to use your calculator to square a negative 2? But if you do, then you need to put parentheses around it. So if you are using your calculator to do any of these evaluations, anytime you raise a negative number to a power, always get in the habit of putting parentheses around it. So let's go back to this problem. So we're going to have 8 times 5. Let me mention this. When you have this fraction bar means divide. It's as if there is parentheses around the numerator and around the denominator. You have to evaluate the numerator and denominator separately. The last thing you are going to do is to divide. So 8 times 5 times negative 2 is, let's see, we get 40 times negative 2 is negative 80, plus negative 1 cubed, negative 1 times negative 1 is positive 1, times negative 1 again is negative 1. So we're going to have negative 81 in the numerator. And in the denominator, we square a negative 2, we get a positive 4, plus 5, we get 9. Last thing we do is divide, so our answer is negative 9. All right? Go ahead and try this problem. Again, pause it, work the problem out, restart the video. Okay, you should have gotten negative 23 as an answer. Again, pause it and go back and see if you can figure out your mistake if you made a mistake. Next problem. Find the area of a trapezoid with base lengths of 13 meters and 25 meters and a height of 8 meters. Now, first of all, you're going to have to remember, how do you find the area of a trapezoid? And in your agenda, you should have a list of formulas. You're going to have to remember some of these basic things. You might even have to start by reminding yourself, what is a trapezoid? So let me draw you an example of a trapezoid. Trapezoids have one pair of parallel sides, so something like this would be a trapezoid. Not a very good one. We have base lengths of 13 and 25 meters. So I'll label those. And a height of 8 meters. Remember, your height has to form a right angle with the bases. And we're trying to find the area. Okay, well, let's think about the formula. To find the area of a trapezoid, we add the two bases, multiply by the height, and we divide by 2. And you might wonder where that formula comes from, so let me remind you. If I took a carbon copy of this and flipped it over, let's say I put a 25 meter length here, a 13 meter length here. So if this is 25 meters, this is 13 meters, and now I have a parallelogram. To find the area of a parallelogram, you have to have the base times the height. 25 plus 13 times 8. That's exactly what I did here. But I don't want the parallelogram, I want the trapezoid, and that's only half of the amount, so I divide by 2. So then we have, oh, I actually substituted it in. I guess I should have written it like this. Base 1 plus base 2 times the height divided by 2. And then we would substitute those values. Now you can actually do a little bit of canceling here first. The 2 and the 8, you can reduce that first. So that's a little shortcut trick. 13 plus 25, so we get 38 times 4. So 8 times 4 is 32, so the 3 carries. So I have 152, and that would be square meters. And that's my answer. Here is your last problem to try. Once again, now this time they give you the formula. So you are actually going to substitute those values in. So pause this, work the problem out, and then come back to this. Okay, so on this one you should have gotten 50 cubic centimeters, and I'm going to actually go ahead and take a look at this one for you. The formula is given here for the volume. 1/3 capital B is the area of the base, and it tells you that in the problem, times the height. So we need to find the area of the base, and it looks like here we have a square base. So to find the area of the base, 5 times 5, area of a square, so we get 25. So we have 1/3 times 25 times the height, which is 6. And I can, since they're whole numbers, I'm going to do a little bit of cross-canceling. The 3 goes into 3 one time, 3 goes into 6 2 times, and then we get 50. Now, how to get the units, because you can get the units the same way. Units multiply, so to get the area of the base, we had centimeters times centimeters, which was centimeters squared, but then we multiplied by the height, which was also centimeters, which gives us centimeters cubed, and that's how you get that answer.